Hello everyone. In this video we are going to discuss one of the most important topic for vector quantization, that is LBG algorithm. Its full form is Linde-Buzo-Gray algorithm. This algorithm is used to design the code book of the quantizer. Now what is code book? As we already discussed, first the input source data is divided into blocks or vectors which are called training vectors. So from the first the input source data is divided and each block is represented by vector. So these are called training vectors. From that training vectors we select some vectors as representative vectors, and the set of these representative vectors is called codebook. So each vector in the codebook is called code vector. So there is some training vectors for the input, and from that training vector some vectors are selected as representative vectors, and set of these representative vectors is called codebook, and the vector in code book is called code vector. There are a number of approaches for designing code book, but LBG is most popular approach for obtaining vector quantizer code book. Here the set of quantizer output points are called as code book of the quantizer, right? And the process of placing these output points is referred to as codebook design. Now, the most popular approach to design a vector quantizer codebook is clustering procedure known as K-means algorithm. LBG algorithm is based on this K-means algorithm, which is clustering procedure. This K-means algorithm is developed for pattern recognition in data mining. This K-means algorithm is used in data mining, which groups the objects into clusters or groups so that the similarity between objects in one group is high and the similarity between objects in different groups is lower. Before discussing LBG algorithm, we will discuss K-means algorithm. This is K-means algorithm. We have large set of output vectors which are called as training set. There is from that training set some vectors are selected, some initial set of vectors are selected which are called as representative vectors. Only initial set of key vectors are selected from the training set, which is representative set. Now we assign each element of training set to the closest representative vector. So after an element is assigned, this representative vector is updated by computing the centroid of the training set vectors which are assigned to it. Here the representative set is updated by computing the centroid of the training set vectors which are assigned to it. So first you have training set. For that, from that training set you are selecting some k vectors as a representative vectors. Then after selecting the representative vectors, each training vectors are assigned to the representative vector, nearest representative vector. So after assigning all the training vectors to the representative vectors, the value of representative vector is updated by computing the centroid of the training set assigned to that representative vector. So LBG algorithm is totally based on this K-means algorithm. LBG algorithm, consider the last line in this slide. LBG algorithm guarantees that the distortion from one iteration to the next will not increase. This LBG algorithm works in iteration, so from one iteration to next, distortion will not increase. While updating the representative vector, the distortion will not increase. Now let us discuss LBG algorithm. The first step in LBG algorithm is to choose initial set of code vectors. Choose initial set of code vectors or representative vectors from the training set. Each code vectors or representative vectors are represented by Ri, and select some tolerance value E. First step is set m equals to 1, which is for iteration, number of iterations, and set distortion equals to this, infinity. So first step is choose initial set of code vectors from the training set and fix some tolerance value. Fix the value of m equals to 1 and distortion equals to infinity. Now there is while loop. In while loop, the first step is divide m training vectors into L number of clusters. Each cluster is represented by Ki, where I is from 1 to L. Use minimum distortion condition for placing training vectors into cluster. The condition is x belongs to cluster, this condition, x belongs to cluster Ki only if the distortion between x and Ri is minimum. Here Ri is representative vector or code vector for cluster Ki. So if x belongs to cluster Ki, if the distortion between x and Ri is minimum, then distortion between x and all other code vectors Rj in the codebook. Here Ri is representative vector for the cluster Ki. So place training vector x into cluster Ki only when the distortion is minimum between x and Ri. Now the next step is to compute the average distortion using this equation. You have to compute the average distortion between all the training vectors and representative vectors. Next step is to compute the centroid of the training vectors in each cluster Ki and make this centroid as a new code vector Ri in Ki. Now the next step is to check for the condition. This dm minus 1 is the distortion value for the previous iteration and dm is the distortion value for this iteration. This equation is checked, and if this condition is satisfied, then execution of the algorithm is stopped. Otherwise, m's value is incremented by 1 and another iteration is started from this while loop. Yeah. So the first step in LBG algorithm is to choose initial set of representative vectors or code vectors, set the value of m and set the value of distortion. Then while loop comes. In while loop, you have to divide m training vectors into L clusters, L number of clusters using minimum distortion condition, this condition. Then the next step is to compute the average distortion between all the training vectors and the representative vector for that training vectors. Then next step is to compute the centroid of the clusters. The centroid of the cluster can be computed by the mean value of all the training vectors in that particular cluster. So next step is to check for this condition. If this condition is satisfied, then the algorithm is terminated. Otherwise, next iteration is started. Now this is the graphical representation of codebook generation process of LBG algorithm. Here, as you can see, there is large number of training vectors represented by dots. From that training vectors, representative vectors or code vectors are randomly selected. In the figure, the representative vectors are denoted by square, as you can see here. The representative vectors are denoted by square. So the initial code book will contain the representative vectors only here. The initial code book will only contain the representative vector. Here only there are three vectors that are selected as representative vectors. So only three buckets or clusters are there for each representative vector. Now for the remaining training vectors, code vector is found which have minimum distortion, and then training vector is put in that bin or cluster. So intermediate code book will look like this. For each training vector you have to find out that which representative vector have minimum distortion. So place the training vector in that representative vector bucket or cluster. So this is initial intermediate code book. Now the next step is to find average distortion using this equation, right? You have to find the average distortion between all the training vectors and the representative vectors which are assigned to it. If the distortion value is not updated, the convergence is there, then stop the algorithm and take the set of vectors which are represented by square as a code book. Otherwise, if the average distortion is updated, then this is the case, then find the new representative vector in each bin or cluster that minimize error. How would you calculate the centroid of the cluster? By taking the mean of all the training vectors present in that bin or cluster. So you will get updated code book. So this is the updated code book. Then again find the average distortion. If the distortion is updated, then follow the same procedure. If distortion is not updated, then the algorithm is stopped and you will take the set of vectors which are represented by square as a code book. So I hope you have understood. In the next video, I will explain this LBG algorithm by taking one example. Thank you.